Okay, so one of the big ideas in this section is thinking about a method for division called the scaffold method. And I really like this method because there's actually quite a bit of flexibility involved, meaning that you can take the steps that make most sense to you, which isn't always the case in an algorithm. So let's look at this problem. We're going to be solving 439 divided by 16. And in order to make sense of the scaffold method for division, you really have to think of division as a how many groups problem, which means that we have a total of 439, and we're going to think of our group size as 16. So we're going to be making groups of 16, and our question is how many groups can we make? So here's where the flexibility part comes in that I really like. And one thing I always recommend is before you even start, you can make yourself a little thought bubble over here or anywhere you like, where you brainstorm like what are some multiples of the divisor, so in this case 16, that are readily available to me. So like I think, oh, well, I know that 10 times 16 is 160. That's super useful. Maybe I could cut that in half and know that 5 times 16 is 80. What else? I don't have to think of too much here, but maybe I could think of 2 times 16. I know that's 32. So there's no rules here over in your thought bubble, but it's nice to sort of brainstorm some multiples that might be useful to you. So I'm going to start by thinking about making 10 groups of 16. So up here, I'm going to notate a 10 because I'm going to use 10 groups, and then that will use up 160 from my total. And I can write over here, even myself a little note. I can say this is 10 groups of 16. Let's see. Notice that I'm keeping my place values for all my numbers the whole time. Like there's no blank spots in the ones place like you would see in the standard algorithm. So I really like this algorithm for that purpose, that you always are working with the numbers with their complete values. Okay, so 9, and then we have 13 tens minus 6 tens. That will give us 7 tens, and then 300 minus 100 gives us 200. I have 279 to go. So I can see I can go ahead and sort of do a repeat here. Use up another 10 groups of 16. And here the book stacks the number of groups vertically. I like to go horizontally. It's totally just up to you, whichever one you like better. Okay. Let's see how much we have left. $119. So here's where I look over at my thought bubble and I'm like, oh, well, maybe I'll use up an 80. So that would be 5 groups of 16. Don't forget to put your 5 up there for your 5 groups of 16. $39 left to go, and I happen to remember that 2 groups of 16 is 32, and that's going to be all the groups that I can make, huh? I'm going to end up with a remainder of 7. Used 2 groups of size 16. That was the last packaging up that I needed to do. Mark it on top, and then I can add up all my groups. So 10 plus 10 is 20, plus 5 is 25, plus 2 more is 27, and I still have a remainder of 7. So that's my answer. I was able to make 27 groups of 16, and I have a remainder of 7. So another way to express this answer would be 27, and the next group is only 7/16 of the way filled up. So either way, depending on the context, 27 remainder 7 or 27 and 7/16. So that's an example of the scaffold method that relies on a how many groups way of thinking about division. Okay, so now let's look at the common method for division, or otherwise known as long division. You might remember learning this algorithm and finding it pretty complex when you were a kiddo, and even when you're an adult, maybe. And just so you know, this algorithm is still part of our standards, but it has been pushed up to 6th grade. So if you're teaching K-5, you won't be, or you shouldn't be teaching this algorithm. You might be teaching the previous methods, so the partial quotients or scaffolding method if you're teaching 5th grade. Anyhow, so we have here 439 divided by 16. It's the same problem that we just solved. To make sense of this method, we're going to think about division in the other grouping way, so in the how much in a group way. And that's just the way that these steps make sense. So one thing that's interesting is I'm going to start by looking at, oh, okay, can I put 16 into 4? And that is actually misleading language, because that would be 16 going into something. That would be thinking about division as how many groups. So what we actually mean when we're asking this question, what we want to ask is, can I split 4 hundreds across 16 groups without breaking up any of the hundreds? Not if I want to distribute things equally. So I'm going to need to break up my 4 hundreds into how many tens? 40 tens. And now I'm focusing right here. I'm looking at 43 tens. And I'm asking, okay, so how many tens go in each of 16 groups if I put them into groups evenly? So that's the question we're really asking. So we have 43 tens, and we're saying how many tens go into each of 16 groups if I put them into groups evenly? Okay, so here's where there's no flexibility in this algorithm. You just have to pass out as many tens as you possibly can. There's no room for flexibility here. So let's see. If I give 1 10 away, that's 16. 1 10 to each group. 2 tens to each group will be 32. And I don't think I can do 3 tens for each group. Okay, so I did 2 in the tens place, 2 tens for each group. And that used up 32 tens. And now I have left over 119. And I actually have to think about this in such a way that I'm like, okay, I need to break up all 119 into ones. We've already distributed as many tens as we can. So this is pretty intense here. So now I have 119 ones, and I'm saying how many ones go in each of 16 groups. So you can imagine I'm building my groups. I'm not going to draw 16 groups, but here's one of my groups. And so far I've put in 2 tens, right? I'm going to draw like a 10 bar. So far I've put in 2 tens. And now I need to think about how many ones would go into each of 16 groups. If I put them into groups evenly. Okay, so here's where it's scratch work. You've got to put as many ones into 16 groups as you possibly can, all in this one step, according to this algorithm. Okay, so 16 times 5, we knew that from earlier, that's 80. So 16 times 6 would be 96, because I added another group of 16. 16 times 7. Let's see. 96 plus 10 is 106. Plus 6 is 112. Okay, sweet. There I am. That's the maximum I can go to. So I'm using 112 ones, and I put 7 ones into each of my 16 groups. 1, 2, 3, 4, 5, 6, 7. And I have a remainder, just like we did with the last problem, because these are actually the same numbers. So I end up with 27 remainder 7, or I could write it as 27 and 7/16 equivalently. So that's making sense of the standard or the common method for division, also known as long division. Pretty intense, but also kind of interesting to think about what's actually going on with that algorithm that we all were very likely exposed to in our childhood.